everybody. Thanks for coming to the Q3 meetup of the OpenStack Toronto. On finally what looks like fall. Probably you guys had the same crazy weather as we did in Montreal. It's 40 degrees when it's not supposed to. So thanks for coming. Quick agenda. I'm just going to do a quick intro and reminders and things around OpenStack and other projects also that are around OpenStack. Give you an idea what's going on. And then we'll have a talk from George and Jared from OICR in regards to OpenStack and their Ceph environment in production here at the Ontario Institute of Cancer Research. Then we'll take a quick break, or like it could be like even just like 5 minutes, like bio break, and then come back. And because I know it's time is always important if you're eating and getting the train or something, want to keep on schedule. Then we'll wrap things up with a day 2 operation talk from Dirk of Dynatrace. And by saying a vendor name, just want to clarify a thing, it's not a vendor pitch. It's open source technologies to do day 2 operation, and also at the end a bit on what their way of doing it also. And he flew in from Austria to do the Ottawa, Montreal, and Toronto meetup. So this last time I'm saying it, man. So let's get going. I just want to say, yeah, thanks to our sponsors. Those are the ones that are actually paying for like the food, the drinks, OICR for the venue, CloudUps for actually allowing me to get paid and do things like this while after that going back the week after and have to do some, let's say, real work around OpenStack. Dynatrace, this time as a sponsor. And Juniper, who's a global sponsor. So the idea of the sponsorship is that if anybody's interested as a company, it's really to help drive the meetups. It's not necessarily like, it's not a showcase window to do, it's just your name is there. If you want to talk about something that's good for the community, fine. If you want to do a sales pitch, not fine. So that's the idea. So updates and speakers, just for you who are at your first Toronto meetup, since we kind of rebooted things. My name is Stacy Verono. With the accent, I'm coming from Montreal. And I work as a director of OpenStack solution at CloudOps, which is a in the wrapper, we're a service company. So we'll help customers own their journey in the cloud. That's the tagline. So if you're doing AWS, GC, Azure, OpenStack, CloudStack, we'll help you out regardless of the technology you need. Of course, well, for me, I have a strong stake in OpenStack, so I'll help you do anything that's OpenStack. And on top of that, well, we do also some not formal training with certification. We do workshops to help you ramp up on Ceph, on Kubernetes, and on OpenStack itself, of course. So that's me. I've been using public cloud for a while, OpenStack also for a while, and MeetUp organizer, obviously. And also recently an OpenStack mentor through the OpenStack Foundation. So they're pairing you with somebody who wants to ramp up in business or technology related to OpenStack, of course. And you find a schedule. So I'm meet up with a lady from Bangalore. She's working at Hitachi, and she's doing some OpenStack, upstream some code in Neutron and everything, and then we're get things going with her. See, like she wants to change path of career, like, okay, as maybe a cloud engineer, what should I do? Maybe quit Hitachi because they're stopped doing some OpenStack stuff. So all those things. So, and she has a strong interest in Ceph, so we're gonna get going and talk about that. So that's the type of thing that are happening as a mentor. It's just taking some of the time when possible to share knowledge with others. So we have two speakers from OICR. We have George and Jared that will talk about, like I mentioned with the agenda, their Ceph cluster in production, how many clusters, the size of the cluster, how many cores they're running for Ceph, and see if they hit that target for the Q3 meetup. They wanted more storage in place, so we'll see if that's true. Second speaker, like I mentioned, Dirk, which again, I won't say your last name, I'll let you do that. From Dynatrace, we will actually talk about day 2 operation. So what happens when you're all set up and ready to go? The ops guys need to figure out what's going on. We'll have a segue through what the OICR guys are actually doing with their dashboard of this is how they're running like operation. So there'll be a nice segue there through other open source solution and also the Dynatrace solution, of course. So we have a new OpenStack version called Pike. 16 release was released at the end of August. It's going to be followed by Queens and Rocky, which were the voted selected names for the next two releases. There's a grocery list of new stuff that's happening in OpenStack, like any release. I just highlighted a few that I found interesting per project. So in Nova, there's a way of telling nodes to remove themselves if they're unhealthy. There's also a way of keeping an instance to consume all the CPU on one host. And if you're doing anything that's PCI related, PCI meaning the payment card industry, there's something in the scheduler called the PCI where. So basically, if that scheduler int is in place, when you put a workload, if that workload is not tagged as a certified workload for PCI, it won't get on the infrastructure that's been validated for payment card industry. So that's a pretty good thing. So when I saw that with past lives, I did some PCI infrastructure. So well, that's pretty convenient. If you're doing even just like mobile payment or anything doing with everything that's online that's gathering payment information. In Neutron, there's a 0 downtimes from Okata. And for the third time, I'll say it again, anybody who does that and it actually works, let us know. It's supposed to work, so we'll see. Improve stability and performance like many of the other projects. There's some QoS on DVR also that's good. So if you're using the distributed virtual routers on your compute, some tweaking on the quality of service. And also if you have multi-port per node or per instance, you can actually tag a DNS domain per port, which you couldn't do before. So that's for Neutron. Cinder, you can revert snapshot, which is good. And you can also stretch a volume that's attached live under certain condition. The conditions were just saying, they were just mentioned under certain conditions. So like figure it out. So this is that, yay. So big guess, like, yeah, well, you need like shared storage. So either you're doing LVM or Ceph, you're good. If you have a third-party solution, like a NetApp, SolidFire, things like that, your mileage may vary. That's probably it. It's like, hey, if the vendors didn't update their drivers to fit it properly, then A, you won't get it. So that's for Cinder. Horizon, for those of you who are using it. I do. There's the clouds.yaml file. So for those of you who are familiar with OpenStack, you log in, you download your OpenRC. Then if you have 15 environment, you have 15 OpenRC file running around with asking for password and everything. The cloud.yaml actually, it's a YAML structure. It goes the same thing that Kubernetes is doing. Is that when you log in, that's on your admin node or your master node where you're connecting with your client, you'll have a .config/cloud.yaml, and in there you'll have a structure, a block of config per cloud environment that you have. The only thing that you have to do after that is just to say, well, with the OpenStack CLI, --os_cloud equal production equals QA dev, and then you switch environment without having to download 20 OpenRC files. So it's pretty cool. And it's coming straight from what they're doing in Kubernetes for some of the CLI. So just using the same approach makes sense. In the UI, there's some new features where create and delete ports for your network. It's not like we couldn't do that before, but now we can do it in the UI, which was not there before. And you can actually see which security group are applied to which Neutron ports, which is something also that we couldn't do before. You have to go in the CLI and do it. And again, for the third time, the domain dropdown, it's something that's listed. It's something that I've installed Pike, and it's something I'm still looking for. It's listed as a feature. So my understanding was that you go on Horizon, you go to the login. If you define multiple domains or even just one for your environment, when you log in, you'll have like domain user password. So instead of typing in your domain, if you have a single domain, which is useless, you'll have probably default and something else as a drop down, so you can actually not have people opening tickets because they made a typo. So, but I'm still looking for that. So I'll probably ping the PTL and say, hey, what's going on? Help me out. Swift, there's globally distributed erasure coding. Swift on its own is a pretty mature project. So in terms of new features, it's always like 2 or 3. So that's one of them if you're doing erasure coding with Swift. Oscillometer for what's left of oscillometer would be the latest releases. Supports metrics from Manila and some SDN controllers. So anybody who's using oscillometer, there's decoupling and changing of time series database and multiple things that are happening. So we'll see where it goes. Yoki was there, now it's not there, but you can still use it because it's still an open source project. So it's a bit of a mess. So the oscillometer API itself is not exposing anything for metrics, so you have to find another way of getting them. So you're talking to your time series database for that. After that, it's basically like if you want to go back with Murano, not Murano, but MongoDB, like we did before, fine. If you want to stick with Gnocchi or OpenTSDB, maybe whatever time series database you want to use, then feel free. Last slide on Pike. So just covering some interesting stuff like in Ironic, you can boot from a Cinder volume. You can actually get awareness of a physical network, which is kind of cool when you're doing bare metal as a service. Rolling upgrades, that's also a good thing. If you're using CephFS, you can basically expose the NFS mount points inside Manila directly. So there's now a link between Manila and CephFS through the NFS protocol, which is good. If you're using Magnum, how many people know about Magnum? Just like 1, 2, 3. Cool. Okay, yeah. So Magnum is basically a container as a service. So you go in and say, I want a Kubernetes cluster. So you define your values. You've set up a template before, and then you cross fingers, and most of the time it works. So right now, if you deploy Kubernetes cluster, the UI from Kubernetes is actually deployed, but also they give you a monitoring stack also, so you can actually see what's going on inside the cluster, which is kind of cool. 2 links at the bottom. Those slides will be shared, were recorded also, but we'll pull them in SlideShare also. There's a link from the video from the foundation itself of what's new in Pike, and the official release, the release notes from the foundation also as a second link. And to make a nice segue with our friends from OICR, I said, hello, Luminous. This is not an OpenStack project, Ceph, but it's the storage that's deployed alongside OpenStack most of the time. So, and one day before Pike release, we got the next LTS release, long-term support from Ceph called Luminous, which will be followed by Mimic, which is just see it the same way we're doing like Ubuntu stuff. Like the LTS is good, like the interim one. New features, new version of stuff are good, but when it's time to upgrade, sometimes it's an issue. If you're trying to upgrade from Joule to Luminous, I did just upgrade my cluster, and it upgraded my cluster. Of course, it didn't put the new engine and everything because I already have a running cluster. But if you're already running Kraken, which was the one right before Luminous, and you said upgrade, it was a 2-page procedure. So LTS to LTS, you're good. So that's and if you add when you add new node to your cluster, you'll get the new Blue Store engine, which is the one that, since this is all open source, it strips stuff. There's an XFS layer when you do Ceph. It strips that layer completely. So there's a new database mechanism and a stripped down OS that's running in there, and you access the block, the storage directly. Each drives are accessed directly now, so you don't have that extra layer of XFS. So on paper, they're saying that you're getting 3 times the speed on the same hardware as before just by changing the engine, which is super interesting. Last meetup, there was Mohammed from VexHost. He's running a Ceph everywhere for their cloud in production, their public cloud running OpenStack. So for them, it's like, yes, okay, so I'm going to start looking at that because it's really interesting. Also, the notion of journal that might actually disappear. Well, they don't disappear. Is that right now there's like, per X amount of drive, put 1 journal to write first, and then it gets replicated. Right now, you have a small piece of journal per spinning disk or SSD that's allocated for at the OS level. So we'll see how it works, and if it's actually like you're able to get more storage and more speed out of the same hardware just by upgrading. So maybe we'll have a talk where Jared and George will tell us like don't do it, or maybe like it's awesome. We'll see. Hopefully the latter. But yeah. So there's also a dashboard that was reintroduced. So it's pretty basic dashboard, but also good to see that you can actually see what's going on in your cluster without having to go in the CLI. So it's something that that's possible through a new daemon called a manager, and the manager exposes metrics. So if you have if you're using Grafana, Kibana, or Prometheus, then you can just tap into it and get the data out. So hey guys, no problem. There's still some pizza, and feel free. The real talk will start in like 5 minutes, so don't worry. So yeah, again, at the bottom, the link to the latest release, and there's a blog post on Ceph there's been blog posts for the last 2 weeks, back to back about new features and people doing some testing to give an idea of what's going on. So it's a good it's a bunch of good reads also in there. I'm almost done. OpenStack Days Canada. Last year, there was an OpenStack Days Canada in Montreal. So OpenStack Days were created for a region where there was no summit coming for OpenStack. It started in Japan. Now, yes, we had one summit in Vancouver, and we're gonna get another summit in Vancouver again next year. But in between that, we had Montreal, and this time we have Ottawa, who's going to host one on October 19th at the Nature Museum. So it's a great venue. Expecting 300 people roughly. I'm part of the steering committee, so if I'm looking at the speakers, about like 15 speakers going to be there, followed by a networking event also, like at the site. So we're not going anywhere else. So, and the price is, I think the admission was like $30 or $50. So if you're ever in the Ottawa region for the 19th, just go on the website and have a look and register. I know the speakers are selected because I got the list this morning. They just need to be uploaded on the website and with the official schedule. And with that, the last slide for me before I pass the mic to George and Jared. For those of you who don't know, we have a Slack channel across Canada for OpenStack users. So you can either like get in the long ass URL that's there. If you're the first one to go in a while, Eriku sometimes takes a while to give your Node.js stuff, but just give it time, it's gonna come there. And then it's self-registration on the Slack channel. It's no invite, so I'm not getting your email address or anything. You're just self-registering, and then you just go in, or you just take the QR code if you want to. And it's everybody across the country that wants to join. So it's the full idea of community behind that. It's people working together. We had George asking question about Kubernetes because I had one of my guys that's good on there that was on that channel. We had Mohammed who was debugging people that had question with Magnum. Other people had other questions around OpenStack, and it's not vendor specific. It's like, yeah, I got it from Red Hat who's helping a guy from Ubuntu, from Canonical, not a problem. So that's the idea. So feel free. We're, what, 150 or something? Close to? Yeah, we'll have, I think like 144, 145. We had 2 new members, so maybe more today. So feel free to join. Like I said, it's not a trap for vendors that are hiding behind the bushes and just like, hey, I want to sell you this. Yeah, it's, and if so, tell us, we'll ban them. So, but yeah, so feel free to join. And that's it for me. So thanks for letting me that little time to present you that information, and I'll let George take over. Thank you. You want me to show you a timer? Are you good?
Okay. I think I'm good. 146 in general.
Woohoo! All right, so we're 146.
Okay. Hello, everyone. Thanks for coming. My name is George Mihesco. I'm the cloud architect with OnTerrorist for Cancer Research. And I'm here with my colleague Jared Baker, who's a cloud engineer supporting the environment that we are working with. So I started working with OpenStack about 6.5 years ago, the Cactus release. I was sent by the company I was working at the Boston conference, the first public OpenStack conference in Boston, 2011. I was a speaker in Barcelona last year and in Boston this year. And I'm pretty active in the scientific working group of OpenStack, also the local MeetUp. Cancer Genome Collaboratory is a cloud computing environment built by OICR. It enables large-scale research on the world's largest cancer genome dataset, currently produced by ICGC. Collaboratory was built entirely using open source software like Ceph and OpenStack, of course. It's based on a 4-year research grant that had, among other goals, the main infrastructure goal was to build this cloud computing that is going to be used by cancer researchers across the world, and it's supposed to provide 3,000 cores, that's in the grant document, and 15 petabytes of storage. ICGC is an International Cancer Genome Consortium, a voluntary scientific organization with members from all over the world. And it's the largest global project of its kind. So basically it focuses on the 50 most common types of cancer, okay? So the researchers decided to approach finding the cure for basically the cancer that affect most people on the planet. And the goal of the project was to enroll at least 500 patients for each cancer type. Okay, so for liver, for skin, for brain, for every common type of cancer, at least 500 DNA samples. And for each type of cancer, they collect data from at least 2 countries. So each, like liver project, it has at least 2 countries that participate in collecting data and sequencing the DNA of liver cancer patients. So because cancer has a great variety in the tumors, they wanted to see if the tumors are basically the same across different genetic backgrounds, environments, and so on. And it was very important to analyze all this data collected using uniform algorithms and uniform methods, okay? Because if a lab in Germany analyzes something, the results could be different if a lab in France does it, because they use different methods. You change something very little, but the impact could be major. So you have to be consistent in the way you analyze this amount of data. Genomic workloads. Before I started the design, I had a few months working with bioinformaticians and researchers in the project, and I also ran some analysis. So I was able to see firsthand how analysis happens, and I was able to monitor the systems that were doing the analysis and see how they stress the resources. Okay, I'm going to give you a breakdown of how it happens. Basically, the VMs, the researchers start very large VMs with many cores, CPU, and memory, and disk. They download the data sets. For each cancer patient, we have 2 data sets, at least 2. One is, it's called a normal. It's basically the DNA of piece of tissue, usually blood, okay? That's not cancer impacted, and DNA from a biopsy of the cancer tumor. So they download these 2 very large data sets, usually 150 to 200 gigs per file. And then, depending on analysis, if you do mutation calling, which basically is like a diff between the 2 files, it's not just a diff, it's more than that, but it compares what is in the DNA of normal sample versus the tumor. You find the genes and the parts in the DNA that change. And the result is much smaller, 5-10 gigabytes. But the first step is the sequencing machine generates a file which is called an unaligned BAM file, which is a specific bioinformatic format. And that one is like a book that has all the pages out of order. And you need basically an index or a reference genome, okay? So you can basically put the DNA points in the right order, okay? And basically you feed the algorithms 200 gigs, and the result is 200 and something gigs, okay? Just it is aligned. And then you can discard the original data if you want. You just keep the aligned file. But the process, as I said, sometimes generates as much data plus something as you entered. And we recommend the researchers that work in collaboratory to basically design their workflows in a cloud way. So basically do not have single point of failures. if you have a server crashing or a VM dying or whatever, you don't impact 50 analyses and you lose 10 days of work for 50 samples. You lose 10 days of work maybe for one sample, which you can easily reschedule, okay? Because we build for scale, we don't build for perfect SLA. And we see Docker being used more and more for portability of the algorithms and consistency in running the same workflows on different systems. This is, I'm going to show on a few slides how the resources are used during the analysis. This is a workflow I ran personally, and it was about 12 days on a VM with 8 cores. The blue line is the CPU usage, the user time, if you can see. So basically the average for user time over 12 days was 99.95%. Okay, so very little idling. And you can see that basically in different steps of the process, some of the steps in this workflow are well parallelized, so they use all the cores. Other steps, when like they merge results or to do other things serialized, they don't use all the cores, okay? But nevertheless, this tells me that I cannot oversubscribe resources on compute nodes where these genomics workloads run, because those CPUs are not going to deal very well with 100% utilization. You have 40 cores and you schedule VMs that use 160 cores or whatever. So oversubscription is not in cards for genomics. Memory usage. This VM had 48 gigs. Most of the time you use like 12 gigs, but there are times when it dropped up to 25. So this shows me that basically, even if it's not using all the memory all the time, you still have to give it enough to make sure that the workflow doesn't fail midway. I/O usage, there is 400 IOPS at the beginning when the data is downloaded, and then not much, and then another spike, I guess, when it's writing some temporary results. And then during most of the time, like 8 days, it was very little activity because the algorithms read in large chunks, 1 megabyte at a time, okay, run in memory the computation, and then they write the result, okay? So it's not a database that reads and writes in 4K blocks. It's large chunks, which means that I didn't have to provide the compute nodes with very fast disks, okay, and build it for very IO-intensive operation. In conclusion, modern cancer research relies on large-scale studies because of the extreme diversity of the mutations. Being able to run more workflows and analyze more data gives researchers more confidence that the insight that the insight provided is correct. You cannot draw a conclusion on a treatment model if you run this analysis on 50 samples or 50 patients. You have to run it on hundreds, okay? Because before you have confidence that, yeah, that's the conclusion I'm going to recommend. Like, so it's important to run more, even if it's lower. Then do it very fast, but you only afford to do it on a few samples because your environment limits on how much capacity you have. So we decided that capacity was more important than speed. Also, building for high performance is much more expensive, and whatever we build today essentially is going to be only cheaper tomorrow. So if we build something with SSDs today, it's going to be 3 months from now, probably the prices are going to go down even more, or next year. So we can always upgrade parts of the system as they age out, okay, and get faster drives. CPU and memory, we are pretty good there, so that's not a problem. In terms of design philosophy, we knew that if we provide the new OpenStack service that is not very stable or not very well documented, we have to support it. We knew from the beginning that we don't want to spend the money for vendor support instead of buying hardware that's going to actually do the research. So we wanted to basically spend all the money on research and capacity, okay? So it means that also we have to be very careful on what features to implement and how risky they are in terms of support time and us being bottleneck on fighting installation or performance issues. The same with Ceph. If we run a Ceph configuration that's not very well tested, like erasure coding or snapshots on volumes and restores and stuff like that, we have to support it. So we decided basically we are going to store the protected data in the object storage, which is pretty solid. Have just a little bit of space in the cluster reserved for glance images and for Cinder volumes. But the main use case is for Ceph to store the large files as large objects, which is very good for parallel download. And I'll talk about this later. So we don't have projects that are considered not very stable, like Octavia, Trove, other things that are fancy, but with 2 people, we have users to support, and as we are confident in these new projects, we'll introduce them, but not before. This is the hardware architecture. So here's a picture from one of our racks. This is how it looks like. We have 8 storage nodes of 4U chassis. I'm going to show you later. And here we have 4 compute chassis. Each compute chassis has 4 storage nodes. So we have 16 compute nodes per rack. Each of these compute nodes has 40 cores. So we have up to 640 cores per rack. With 8 terabyte drives here, we have 2.3 petabytes per rack. The compute nodes, each of these 4 compute nodes has access to 6 drives in front. We use 2 terabyte SAS drives. We put them in a RAID 10. This gives us about 5.3 terabytes of formatted space. In a RAID 10, we have good redundancy, we have good I/O performance, we have plenty of space. The VMs, when they start, they run from the local disk. If a VM hammers the disk, it only impacts that compute nodes and 2 or 3 other VMs that run there, so it doesn't impact the entire cluster. If it fails, also the failure domain basically is small. The compute nodes have 256 gigs of RAM, okay, and 10 gig network to the Ceph cluster, as well as management and everything else. We use VLANs on top of the network. The average bioinformatics flavor is 8 cores, 48 gigs of RAM, and 1.1 terabytes of disk. Okay. There are flavors that use less cores, but I would say most of them use 8 or more, okay, for parallelism. And the largest protected data object that we have is 800 gigs. So, and that's a tumor with high coverage. Okay, so for somebody to analyze that patient's data, he needs the normal sample, which is probably 200 gigs, plus the 100 gigs, the tumor downloaded, okay, on the local disk to the analysis, which outputs more data. So you need to start it with a flavor that's going to accommodate these disk requirements. The drawback of looking in local storage with OpenStack is that you cannot easily do live migration. But sincerely, when you have 200 VMs in a cluster and you start to move them around, it's very hard to orchestrate this dance of moving VMs from node A to node B to node C, and so on. It's going to take a long time. When the VM is doing this kind of computing analysis with 100% CPU utilization, the live migration is going to fail. Because basically the memory pages change faster than they can be copied, and so live migration is not, and even if you drain a node of 3 VMs that maybe don't have load and are smaller, and you still have one that fails migration, you still didn't do anything because you cannot reboot the node because you still have a VM there. So you either drain it totally or don't do it. So what we do, we basically announce maintenance in advance. The users, we told them, hey, next Tuesday we have to reboot the nodes for 10 minutes. Try not to start analysis that is going to take longer. So if you have a new round of analysis, either make sure it's a smaller type, a shorter type of analysis, or wait until Tuesday we give the go ahead. Okay, so it has drawbacks, but that's how it works right now. Some of the benefits of running mixed racks with compute and storage is that some VMs have Cinder attached volumes for extra space or to save results of the analysis or whatever reasons. And those volumes are basically some of the primary replicas that make up the volume will be in the same rack. So some of the Nova to Cinder traffic is going to stay local to the rack. It's not going to go to other racks, okay? The primary, so faster, at least a little bit faster write performance and read for sure, because the reads always come from the primary replica. Also, the compute nodes take a lot of power. So if we load this rack just with compute, then we have 60 amp circuits, 2 circuits per rack. We probably wouldn't have enough power provided to the rack. So with mixed storage, much less power draw. On the Ceph side, this is a storage node, Supermicro 36 drives, 24 drives in front, 12 drives in the back, 4 10 gig networks. 2 10 gigs are bonded for client traffic, Ceph public, and 2 10 gigs bonded for replication traffic. We have 256 gigs, a lot of RAM. We don't use dedicated journals, okay? No SSD journals. So each drive has its journal on the drive itself, each USB node. We started with 10-core CPUs when we had 4 and 6 terabytes. Now we have 12-core CPUs, so we have 48 cores hyper-threaded per node, but we have a lot of storage per node and a lot of RAM. And this basically allows us to have very large nodes. Like the last batch of servers that we got are 10 terabyte drives, so we have 3.6 petabytes of storage that we are adding in the cluster tomorrow. We'll go into data center. So there are benefits of using large nodes. Basically, you save a lot in terms of space, ports, you cram a lot of capacity, but it's also good to give it a lot of RAM, a lot of CPU in case there are memory leaks, or it also helps with performance. So, and RAM is cheap. We basically save by not paying support, and we spend maybe a little bit more on the hardware specs for the storage nodes. And again, we are not using SSD-based journals. If we use SSD-based journals, then the recommendation is 1:6 ratio. So basically, out of 36 drives, we'd have to use 6 for SSDs, 6 slots. 6 slots, basically, it means 20% of capacity for caching the writes, okay? Caching the writes, which are very large sequential writes. So basically, write fast with SSD, and then you have to stop so SSD can flash. Not a good use of our money. And when you read, you never read from the fast SSD. You still read from the slower disk. So no SSD journals. As I said, we use Ceph as a backend for Glance and Cinder, which allows us to basically scale out images and volumes as we scale out the cluster. The 10% that we reserve for these pools grow as we grow the cluster for object. Ceph performs much better for reads when multiple parts of the large files can be accessed in parallel. So basically, we upload the files, the large genomic files, in 1 gig chunks, and we use 64 megabytes RADOS size. Okay, so we have fewer RADOS objects in the pool, which helps with recovery. Also, the reader head is 8 megabytes, so when the data is read from the drives, it's much faster because of these tunings that we did. This is a graph that shows how rebalancing looks in terms of disk usage. We added here 2 new nodes, the one on the bottom, and you can see the nodes on the top being drained as the data is getting loaded on. So data was moving from rack 3 to rack 4. Okay, this is just a section of our Zabbix graphs. That data was moving much more than that. We have 20-something servers at that moment. But just to give you an idea of how nicely. The drives are being drained as the other drives and new storage are getting loaded with data. The same event, you can see that the replication network, these are the nodes that were receiving, like storage 1 rack 4 was receiving traffic, and you can see basically up to 14 gigabits per second of the 20 that is provided on the backend, which tells us that basically with 36 drives into the node, throughput was not reaching more than 20, so we are not bottlenecked by the network. But if we had only 10, then yes, that would have been a problem. So 20, I think it's a good size for the backend network right now with these 36 SAS drives, 7.4K. Control plane is a pretty standard HA configuration. So we have 2 6-core CPUs, 128 gigs of RAM, so a lot of RAM for the control planes as well, but it's better to give it more for the control plane than less. We use S3700 SSD drives. We had initially 3 RAID 1s, so 6 drives in 3 RAID 1s, but when we upgraded from Ubuntu 14.04 to 16.04, we decided to switch to a RAID 10 with LVM so we can allocate space more when it's needed. Like if the SafeMon partition didn't have enough space, we can grow it instead of have SafeMon running on a SSD on a container that's fixed and you cannot give it more space. We use HA proxy as a load balancer in front of everything that does SSL termination. We use keep alive D for moving the public and the private VIPs around. On the controller plane, we have 14 gigs, and we have just one bond with different VLANs for each type of traffic. We use layer 3 plus 4 hashing for better flow distribution across the 4 ports. On the neutron side, we use GRE tunnels because we deployed it back in the days, and the GRE had better support in OpenStack than VXLAN. And we don't see a problem with GRE. I know that most people use VXLAN now, but why change it if it's working and doesn't cause a problem? Use HA routers, HA DHCP. So basically each tenant network, when the router is created, there are 2 routers, active, passive, that are scheduled dynamically on 2 of the 3 controllers. So each controller has a number of active and passive routers. As we do maintenance, we can migrate them for no user impact. We don't use DVR. We want to basically have connectivity to the internet only through these 3 nodes. Better control and fewer public IPs, and basically better security to know exactly that you only have a few, like the public VLAN is only trunked on ports going to the controllers. In terms of networking, we have a Brocade stack. So we use 7750 Brocade ICX switches. It's an older model from Brocade. Very good switches, I can say, because they have 48 10 gig ports going to the servers, copper, okay, so you don't have fiber, cheaper, no need for transceivers, and they have 640 gig uplinks, okay, and we use TwinAx to connect each top of rack to the left and to the right using TwinAx cables, and we create a ring, okay. There is no special license to do this. And basically, if you have, let's say, a problem between rack 2 and 3, traffic still goes between rack 2, it goes to rack 1, and all the way on the other side of the ring, okay? And you have 2-to-1 subscriptions. You have 480 gigs going down and 240 gigs going to the other racks. And we use TwinAx cables, which are very cheap. You don't need transceivers. The only place where you have transceivers and fiber is between rack 1 and rack 6, because the TwinAx cables are a maximum of 10 meters. Okay, and as we grow, basically, we just here put another top of rack. We take out the transceivers and put TwinAx and move the fiber between 1 and 7. Okay, And you can do this live because basically traffic between rack 2, 3, 4, 5, 6, whatever is going to go on the other side of the ring. And then I'm going to pass it to Jared to continue with the presentation.
No, although it's a year old. Yeah, okay. Yeah, hey everyone, my name's Jared. I work with George as a cloud specialist. New to OpenStack, I've only been working with OpenStack for a year. And I went to my first OpenStack Summit this past May and spoke with George, which was really fun. And I have about 10 years of various IT infrastructure experience, worked with some of the guys in the room here as well. So who are our collaboratory users? Well, they're cancer researchers located across the globe, and many of them belong to academic institutions, and some are similar in nature to OICR. We're home to over 30 projects across 4 continents right now. You can see the map, that's where they are right now. OICR developed a data portal that indexes cancer data across multiple sites, including the collaboratory. And researchers can use this site to select and download specific cancer data of interest. The ICGC data portal has indexed 547 terabytes of data that is currently stored in the collaboratory's object storage. And this is the main driver for use in the collaboratory. So researchers looking to do analysis on ICGC data in the collaboratory is because it's a one-stop shop for a large data repository and compute infrastructure in one place. So that's you can see a screenshot there of the data portal. It's incredibly advanced. Blows my mind to see what bioinformaticians would do with that site. So OICR developed an object storage client designed to securely upload and download large genomic files. This client supports S3, Swift, and Azure, and has the ability to resume interrupted downloads. It's designed to be fast, with a 100 gig file averaging about 25 minutes to download, and maximum throughput achieved was about 31 gigabits during multiple downloads from multiple clients. It also has some advanced features useful to researchers, such as allowing to stream data from a specific chromosome from within the whole genome file. So a big part of collaboratory sustainability is cost recovery or cost sharing. A usage portal and invoicing system has been implemented for all research projects. The usage portal was developed in-house and was part of, as was part of the invoice system. Raul at the back here did the invoicing and FreshBooks integration, which basically provides really easy interface for our users to pay for their services with a credit card. Here's a breakdown of the major upgrades to OpenStack and Ceph since the collaboratory's inception. So Ceph upgrades, we try to stay with the LTS track for simplicity. OpenStack upgrades, we try to stay within a release or two of the current release so that we can still benefit from security and bug fixes being backported. Now, before we upgraded to Newton, we had to upgrade controllers and compute nodes to Ubuntu 16.04 because we were previously on 14.04 and Newton was not available for them. So the controllers were rebuilt from scratch, which helped us eliminate some technical debt, and the compute nodes were upgraded in place with Ubuntu's due release upgrade. Preparing for updates, we make use of virtualized environments to test these new versions. We perform basic configuration testing. We take care of hard deprecations and database upgrades using our database backups. This helps us document the upgrade process for production. We leverage HA proxy to minimize the impact to our users as we roll through the upgrades of each OpenStack component. We make sure to test the functionality of upgraded components one by one, server by server. It is very useful to have historical performance graphs to see if any performance differences existed pre or post upgrade. So with all our funds going to hardware, we're reliant on using basically purely open source software. So we use Ubuntu for our operating systems, OpenStack and Ceph as a backend for Cinder and Glance, Ansible for configuration management, and Metal as a Service for OS provisioning. And all our operational tools are also open source. So let's talk tools. We use Zabbix for general monitoring and alerting of all components in the data center, including the standard operating system metrics. We use Elasticsearch, Logstash, and Kibana, and that's helped us rein in on the sheer amount of logging that happens across all our servers. We've built many different visualizations to help find needles in the haystack and can also trigger alerts just like we do with Zabbix. So these tools and others are key to us being able to manage a large cluster with a small team. So here are some day-to-day operational details that we do. So we use Nova's host aggregates. They're really useful for isolating hosts and instances which can be used for testing, changes to software packages such as security updates or configuration changes. We also use it to define different generations of the flavors that we make available to our users. We let Ceph heal itself to some extent for things like drive failures. If there's a drive failure, we let the cluster rebalance. And then we can work with our on-site technicians to replace the disk, and this all happens transparent to the user. We set up Ceph so that rebalances aren't triggered automatically if like a full rack becomes unavailable, because that's like a whole fault domain, but it'll rebalance for smaller events like a host failing or, as I said, the drive failures. So can you script that? Many scripts have been developed to make our lives easier or to check things that we have experienced silent failures for. For example, we have a script that monitors and keeps our glance images up to date so that we know our users are deploying new instances that are well patched and up to date. If you had to do that manually, it's just more time consuming than it really needs to be. As for transparency, we have a mailing list that we can communicate with our users. We also have a website that has like a status page that we can update so they can know if something is down or if a maintenance is planned. Here's some drive stats. As of like today, we spare 4% of our hard drives on site so that we have replacements available for failures. This helps resolve any immediacy of replacing a disk while we file the paperwork with our vendors to get a replacement, because we have some disk destruction agreements which makes getting a new drive from the vendor kind of long. So all these drives on this chart here are enterprise class drives. And the majority of the drive failures have been from the compute nodes, but overall our drive failures have been low enough to not really be concerned. We also have a collection of SSDs throughout the storage servers for their operating systems, and then our controllers are also exclusively SSD. So we have about 86 SSDs, and none of them have failed yet. So some lessons learned is as you come across issues like silent failures, well, fresh on the mind, write a script to test and monitor it. There's lots of ways OpenStack can break, so use your experience to build up your monitoring checks. And speaking from experience, sometimes those easy tasks can turn out to be a real can of worms. For example, we did a routine batch of security updates that needed to be installed on our controllers, which inadvertently caused an upgrade of our Ceph monitors from like a major version from Hammer to Joule, which broke some things. We can talk about the details on that later, but that was fun to fix. This one's just common sense, but under-speccing something like your control plane or your monitoring infrastructure will only cost you more time and grief in the long run, so be generous with specifically those two areas. And having powerful Ceph storage nodes allows you to have peace of mind from issues, things like maybe you got some memory leaks or performance issues during rebalances. And it even kind of opens the opportunity to hyperconvergence if you wanted to go there. So we have some future plans. Obviously, we need to stay up to date. So running Newton right now, we'd like to upgrade to Okata and then Pike as soon as we can. There's like some bugs in Newton that we'd love to get away from. So obviously we want to do that. Upgrade to Ceph Luminous since we're on Joule right now. And Blue Store. So we might have an opportunity to build a new and larger environment with a spine leaf network architecture. And I know George is really curious on this one, investigating the stability of container-based control planes. And I know both of us are due to write our OpenStack exams. We have to do that before December. So that's all I have. Thank you to our funding agencies, including OICR and the Government of Ontario.
By the way, there was a section about looking at COLA, which is OpenStack container. On the Slack channel, I pasted it, but I'll put it there. Yesterday in Montreal, there was a MeetUp, and one of the talk was from a company that's using COLA in production. So it's their lessons learned. So that's great. And we put it also on the Montreal OpenStack YouTube channel. So yeah, maybe I'll just put it on the MeetUp page. So if you're curious, just have a look. It's always good to have information from the field instead of finding out for yourself what's wrong with COLA.
Do you want to answer questions now or at the end?
Well, it depends how we want to go for time. Technically, we're in like 10 minutes for break time. Then.
Want to take a break, or you want to answer questions, or what do you want to do? Need a break?
Want a break? You want to pursue? You want a bio break?
Yeah, I can show you a little bit of our monitoring stack live.
Sure.
We have a few dashboards. Change this first to last 7 days. Nova API calls, for example. Basically, we see per type of call, number of API calls, the 3 controllers, the response time, so you can see if one controller is slower than the other ones. The OpenStack dashboard, instance creation per whatever the time frame is, half an hour, I see, per hour, okay? General errors, Nova errors. Now, those errors shouldn't scare you. Sometimes OpenStack logs stuff at the error level, but it's not actually service impacting. Very interesting is this part I like a lot, like logs by type and host. So I can see at a glance if, for example, this is Nova Compute, and these are the compute nodes, their logs count. So I see if one compute node logs more, then that compute node might have something to look at. Apache Keystone, again, the 3 controllers that have Keystone running, pretty much equal in terms of loads, so 30% each. CephMon, you see the CephMon one has, controller one has more than the other 2 because the master CephMon runs on controller one that's elected, so I guess logs more. HA proxy controller 2 has more stuff because it holds the VIP, one of the public VIPs, gets more traffic. So basically, I can in the morning and look and see if yesterday or overnight if everything is fine. Okay, Rados gateway errors. You see protect data downloads, switch ports, flaps, internet port flap, slow request for Ceph, a lot of things. Very, very useful tool. Zabbix, again, another excellent free tool. All the servers have agents, Zabbix agents installed, have a lot of custom checks in Zabbix, a lot of graphs, dashboards. I can go and see compute nodes utilization per GRE port. So I can see each compute node, for example, compute 4 rack 1. I think where I have the VM that does the hourly download for testing, every hour see between 5 and 6 and 7 has a lot of in traffic on this interface. That's the GRE interface, Bone 020, okay? So I can see at a glance what happens on each server. So we have 27,000 items collected from 211 devices. And they are compute nodes, storage nodes, switches, PDUs. We can see power usage per rack. Each rack has 2 PDUs. They are 48 usable amps, PDUs. So, for example, rack 2 draws about 10 amps on each circuit. So if this circuit fails, this one has enough capacity to basically support the load of, because each compute node has 2 power supplies, okay? And each power supply draws half of power. But if one circuit that feeds the left side fails, then the power supplies on the right side is going to pull out more power. So you need to have, the circuit has to have enough power to deliver to the power supply, and the PDU has to have capacity, okay? So we have 48 amps PDUs. Again, so a lot of graphs, a lot of alerts, and it's for free. And it runs on a 12-core CPU with 128 gigs of RAM and SSDs for the OS. So you can do a lot.
Are they custom or they're just out of those we can just
Well, basically, we have a lot of templates that come with Zabbix, like Linux operating system templates. We have templates that we got from the Fuel GitHub. Okay, they use Zabbix, and a lot of things that we customize and we build ourselves. As we need. Yes.
Is this a free too or free?
Zabbix?
Yeah.
It's free.
Sorry?
It's free.
Okay. Because they just released free like in the last month. They do really interesting stuff in the last
This is, I think, 3.2. Jared? What version are you running? 3.2?
Of what?
Zabbix.
Not the very latest one.
Yeah.
3.2.
Yeah, we are 3.2 and the 3.4 is the latest one.
3.4 was
But
the
it's free anyway, so even if we upgrade, we ran 2.2 for like 3 years, so you only upgraded to 3.2 half a year ago.
It was super easy, like not being sarcastic. It's really easy.
Yeah. What else? We use Grafana. So basically, this is a rally test that starts an instance every hour, assigns a floating IP, SSHs into the VM, and then pings Google 5 times and captures the number of responses, and then shuts down. And if the VM fail for whatever reason, or if more than 60% of the pings were not responded, this tells me there is a problem maybe either with the VM creation or with connectivity to the internet, drop packets. And this is an end-to-end test that we do every hour. Basically, starts an instance, assigns a floating IP, so that works. I can SSH with the key. It means that SSH key injection worked. I can ping Google, works. So it's end-to-end user experience. The same with the rally. It boots from a rally volume and then does boots from a rally volume and then does a write test.
So if tests
Yeah.
fail, does somebody get paid or what's?
Yeah, we get an email or a Slack.
Is it like one failed test, or do you kind of wait for a set of failed tests? Like, what's your experience?
Well, I get alert right away, but I'm not 24/7. It's 2 people working 9 to 5. So I'm going to see next day that this morning at 2 a.m. it failed. If it's failed 5 times in a row, when I come to work, then I know it's a problem. If it fails at 2 a.m. and it fails for 5 hours, when I get to work, I'll fix it. If it failed just once, I might look in the logs to see what happened around that time, what might have caused the problem. But the SLA, again, is adjusted to the support capabilities in terms of we don't have a 24/7 NOC supporting environment, and people are not paying or losing money if. But I think we are pretty good in terms of availability.
I think we're all for beer one time, and it was like, oh, something broke, and then the phone got put down again. That was it.
Okay, thank you.
Thanks, George. Just let they're set up.
Yeah.
I posted on the MeetUp page the links for the Cola talk, the slide, but also the full video, because we were live broadcasting and recording something.
All right,
Ready when you are.
ready when you are. So I'm going to tell you something about day 2 operations, and George actually did a terrific job in like demonstrating a few of the tools that I was going to demo. So you already saw them, and I can skip a few of my slides. So maybe we will even make it a little bit faster through. So a little bit about me. My name is Dirk. Stacy refrained from pronouncing my last name. So in German it would be Wallersdorfer, and it's just terrible to pronounce in English. That's I always was contemplating of just using Dirk Wall, and that's actually why I came up with my Twitter handle. So I'm from Austria. I flew over here for the Canada OpenStack MeetUp Roadshow. And 3 times in a row pizza, yeah. And I have to admit, it's pretty good. So it wasn't in the first one, it wasn't in Ottawa, but it was pretty good. And it really wasn't that good. So my role is cloud technology strategist at Dynatrace. So it sounds totally funny and fancy. So what it basically means is I get to play around with cloud and container technologies and like to really understand them and get a grasp of where the community is going, where the technologies are going, and like figure out what is the best way to monitor those technologies and like do consulting in-house for our product management team, go out, engage with the community, and yeah, do gigs like this, for example. So Dynatrace, for those of you who don't know Dynatrace, is basically application performance monitoring company. So our background is actually strong on application. So Java applications, .NET applications. And now we actually saw the necessity to expand our monitoring capabilities also to cloud and container technologies, as we always would like to provide you with a full stack view from end user experience down to cloud platform. And yeah, so that's basically why I'm here. And I heard you guys in Canada also know Sound of Music, which is totally funny. Yeah, I've never. So no one in Austria has seen that movie. Nobody knows it. So.
I've reenacted scenes in Salzburg.
Come again?
I've reenacted some scenes in Salzburg.
Seriously?
Don't lie, you've seen it.
Like maybe watch it like 10 times.
So in the yesterday, the people told me they watch it at Christmas every year or something like that.
Whatever the kids want, that's not the music.
Great. So as you see, not all Austrians run around in lederhosen and yodel all day long. So a few of them do, but not all.
So let the post.
Come again?
You said you own a.
Of course I own a
What's
lederhosen.
that?
So it's like the leather shorts, you know?
Oh, right,
the-
okay.
yeah.
So you live in part of Austria without kangaroos? Is that what I understand?
They've got the wallabies.
So it's really, it's amazing. It still happens. So if you talk to anyone in America, in the United States, and you talk Austria, oh yeah, kangaroos. No.
I actually
Not
refrained
even-
from that joke. It's sad that it's actually true.
Yeah, it's really sad. So, but yeah, you come to, yeah, you can deal with it. All right. So day 2 operations. What does day 2 operations actually mean? So day 0 would be the day where you actually get the requirements for your cloud. Try to figure out what you're actually trying to solve. Day 1 would then be like setup of your OpenStack cluster. Day 2 can mean different things. So it could on one hand mean optimizing your OpenStack cluster. So basically what you guys have been doing. Then maintenance, availability monitoring, and just basically making sure it matches the expectations you set at day 0. And to that end, you basically need to have a really good understanding of what's going on in your OpenStack cluster, and that's why you need, to a certain extent, part to monitor it. So there are some tools today we're going to walk through. So there's Nagios, Elastic, Monaska, and Dynatrace. So Nagios is similar to Zabbix, so what George previously demoed. Elasticstack is what he actually had demoed. Then he also showed some Grafana dashboards, which is actually what Monasco uses. And at the end, I'm just gonna briefly want to show you what Dynatrace came up with for OpenStack monitoring. So what all these four tools have in common is they follow the same basic concept. And that is actually that you have some sort of an agent component that actually gathers data, gathers log files, and some server component that does the actual correlation and computation of the data and comes up with a visual representation of that and just makes sense out of the data. And of course, the agent sends the data to the server. So let's start with Nagios. So Nagios is used for monitoring IT infrastructure. You saw the example of Zabbix. It's pretty similar. I think Nagios is around a little bit longer, I guess. And to that end, I basically set up a little demo application consisting of a controller node and 2 compute nodes and 1 Nagios server node. So you basically get a feeling of what are the components that you need to set up if you want to monitor your OpenStack cluster with Nagios. And what you would need to do is basically, so I followed the approach of the Nagios remote plugin executor, which you would need to install on the controller nodes and compute nodes. And you need, of course, to install the Nagios server component on the Nagios server, which could be a VM or a dedicated server, whatever your preference is. And then, of course, you would need to configure it. So on the one hand, you would need to configure on the Nagios server the different servers you would actually want to monitor. So we have it here. So for each node, you usually have a configuration file where you have the checks inside. You want to know the CPU utilization of the server. You want to know the memory utilization, disk, network, stuff like that. And besides the usual checks, you can actually also write your own. So I have done that for an example. So I just wanted to include like the number of VMs that are running on your OpenStack cluster. So I just created an additional check command that's called novalist. Defined the command in the commands configuration file of Nagios, and basically linked to another executable file, which is a bash script in my case. But basically you can use whatever language you like. And then just like did a call to OpenStack server list and counted the number of lines that are not just dashes or like the headlines. And yeah, basically if you do that, you can include the number of VMs that are running easily in your Nagios monitoring. This is a really simple example, but if anything that you can code, you can actually include in your Nagios monitoring. So previously I was doing a demo here, so I'm going to just show you the screenshots of how it looks like. You've seen the Zabbix dashboard. It's pretty similar to what Nagios looks like to a certain extent. So you get basic information about your hosts. Are they up? How is the ping rate? Are they down? Is there any problem with the checks that you have configured for those hosts? And then, for example, so we were talking about the OpenStack instance count check that I have written. So you would basically see this as a service at the controller host. And you can see here that, for example, 2 services are running. So as you can see, Nagios is not only for IT infrastructure monitoring, it can actually do a little bit more, depending on the amount of time you'd like to invest to extend it and write your own checks. And what other people, for example, did, they just used data from Nagios and like have rewritten the UI totally and just like came up with a more fancy UI. So this is just the same data you get from Nagios, just in a different visual representation. So it's the same data, just wrapped differently. So Nagios usually is for monitoring static entities. You have the possibility to monitor VMs that are launched dynamically, but you would need to modify the Nova API code, which could be troublesome. An alternative would be that you choose the Enterprise edition of Nagios, which actually has the capability to do that and has some additional functionalities. And also in the paid version, there is a log server. So basically, you can also do log analytics with Nagios if you pay for it. Everything we saw before was with the Nagios free version. And if you're really interested in what you could actually do with Nagios with regards to OpenStack monitoring, there's a great talk from Nagios World from 2014. Really recommend watching it if you're interested in that. All right, let's take a look at Elastic. So we've heard that the guys at OICR are actually using ElkStack, so it's really cool. So, sorry. So somebody is watching me and they will definitely point out if I'm telling something that's not true. So previously it was known as the ElkStack. Right now it's more known as the Elastic Stack. Basically the tools stayed the same. So the ElkStack was Elasticsearch, Logstash, Kibana. I think George actually did a detailed description about the components before. Elasticsearch for the storage of the data, Logstash for processing of log files and shipping data to Elasticsearch, and Kibana for the visualization. And in the Elastic Stack, there is one new component that's called Beats, which is like a lightweight alternative to Logstash, and has actually has not only the capabilities to ship log files to Elasticsearch, but also like metrics, so system metrics and network usage data, and just has more, let's say, a broader set of metrics or data that you could send into Elasticsearch, but it's not that configurable. So you can't do what you can do with, for example, with Grok and Logstash. You can't do that with Beats, but it's pretty easy to set up and pretty slick actually. Oh, and there is also like Xpack and Cloud. So there's like the paid version for Elastic again. Xpack is like let's say an extension pack. I think actually that's why I called it Xpack, where you get additional, like for something for security, something for alerting. So it was called Watcher previously with the ElkStack, and some graphing and machine learning components. So, and the cloud component is actually the one where Elastic hosts everything for you. And yeah, you just pay them to host it and you can run all of your Elastic Stack there. So what I've done for demo purposes, so usually a ElkStack setup looks something like that. You have Logstash or Beats, so some data input component that pushes data to Elasticsearch, and then you have Kibana that visualizes the data that's coming in. So I was using Beats, and here is actually a list again of the different shippers of data that are available for Beats. You're squinting your eyes so you can't read it. So it's for log files, it's for metrics, it's called metric beat, awesome. For network data, for Windows event logs, and for uptime monitoring. These are like individual services that you would need to set up on the host where you want to ship data from, and they would then send it to Elasticsearch. So following this totally awesome example, this is how it would look like for the Elastic Stack, and I followed the setup with Beats instead of Logstash. So you would set up Beats on the controller and the compute nodes, and like on the fourth server on the side, you would set up Elasticsearch and Kibana. And so the configuration steps, so the slides will be available afterwards, so Stacy will post the link, or I will post the link in the MeetUp group as I'm part of it. You need to set up and configure Elasticsearch, of course. You need to set up and configure Kibana and basically point Kibana to Elasticsearch where it gets the data from. And then, so for this example, I've set up file beats and metric beats. So file beats for log analytics, where you basically need to provide all of the log files you want to analyze in the configuration file of file beat. And then you basically provide the output, which is usually Elasticsearch. And what FileBeat actually provides is something similar to the functionality of Grok with Logstash, what we talked before. There are like pre-built modules for Apache, for Nginx, for MySQL, and for syslog that actually parameterize and tag the log data accordingly out of the box. So you don't have to do it anymore. And then there is metric beats. So the configuration for metric beats looks like that. You basically just tell them, okay, these are the metrics that I want to ship to Elasticsearch, that I could actually graph them and make sense of them later on. let's take a look at that. So you've seen like you've seen how Kibana looks like previously. So I would just like to go through the. You don't see anything, right? It's the same as yesterday. But this time I have the screen here and don't have to write like this, so that is an advantage. So I just want to show you how the configuration actually looks like for this file beats and metric beats stuff for real. Yes, I can. Is it better now? Perfect. So as you can see, there should be 2 services running, and we have them here. So I will make it a little bit bigger. So there is like the file beat service and the metric beat service that are running, and these are just like normal services that just start and are running. And the configuration of the service is actually YAML permission, same as yesterday. Who knows sudo bang bang?
Yeah, hopefully not everybody.
The best command in the world. So in here you actually find the path to the log files where you want to analyze. You can include tags to the log files out of the box. You can include, for example, the log rotation files that are gzipped. And yeah, so as you know, for OpenStack, there are a lot of log files. And I also included one with the Apache 2 module, which is basically, I guess, just the access log file or all of the log files of HTTP service. All right. And for the metric beat, YAML. Yeah, it's basically just what I showed you in the slide before, but here you could actually configure additional metrics or just leave a few of them out. Can provide tags again, and basically provide the output to Elasticsearch. So it's basically just like apt-get install file beats, apt-get install metric beats, one short configuration, and you're done. So yeah, it's pretty easy. So I will spare you the demo of the Kibana dashboard because you've already seen it from George. Here are just 2 examples what you could actually do with that. So you could just like get an overview chart of like what's happening, which service is writing how many log files, and like what are the top 10 sources. These are just examples. And this is an example from CERN, for example. This is their Nova dashboard. Right, so how many requests are there to Nova, how many log messages at which specific log level has there been. And yeah, we've seen the examples before, so I will just skip over to the next one.
That's what I copied.
Really?
Yeah, I saw the set on the dashboard.
Yeah.
I'm going to do on the same.
Yeah. They're pretty cool at CERN.
Yeah.
All right. So Monasca. Who has heard of Monasca? Show of hands. Who's using Monasca? Nobody. So it's really interesting that you don't find that many people that use Monasca. Although it is actually the monitoring project that is really an OpenStack project itself. So it's like the monitoring as a service project, right? And so maybe the architecture that I'm going to briefly cover on the next study is one of the reasons why nobody is going for that. But yeah, I don't know. I wouldn't know. I really would have to talk to all operators out there. Does anyone know anyone that uses Monasca?
Now I know you.
Huh? Well, I'm not. Okay, yeah. So, as before, so it's always the same. So you have an agent. There is like the Monasca agent sitting on the host where you want to monitor. And then you have several components in this Monasca setup. So you have 3 APIs a log API, a metrics API, an event API, and you have then on the bottom like different data storage based on the nature of the files or the data that you want to save. So for log files, it's Elasticsearch. So we're back at square one. For configuration, it's MySQL. And for time series data, it's actually InfluxDB. And what actually happens is that all of the Monasca agents send data to these APIs. Data gets stored in whatever data bucket it belongs to. And then you can actually retrieve data again, either through the Monasca API or, for example, through Grafana. So Monasca uses Grafana. We also saw Grafana dashboards earlier on. Thanks for that. And yeah, so this is basically what the Monasca agent can do. So basically, like system metrics, it can utilize Nagios plugins, which actually it ties additional components in, and basic checks for processes running, are the OpenStack services running, is the HTTP endpoint running and returning 200s, or is it not? So, and it's also extendable if you can know how to write Python.
Is it supposed to run inside the VM or on the compute node?
Usually on the compute node, so I guess. It really depends on what you want to monitor with it. If you want to monitor the applications, it of course makes sense to run it inside the VM, I'd say. If you're only interested in how your control plane is doing and like the compute node resource utilization, stuff like that, I think it's not on operating system level.
Like monitoring as a service, usually as a service means it's used by the tenants to monitor what happens in their VMs. So
To be precise, it's actually monitoring at scale. That's what Monasca stands for.
Yeah.
And not as a service. So it's to monitor the stack, but also the application. So technically, it's a pod of things that can actually just live on their own and connect to your system to monitor it.
Yeah.
You don't monitor yourself on the environment you're monitoring because if it's gone, then you're gone.
Yeah.
But that's probably a reason why there's not much people investing a lot of time where there's some, I think, sleeker solution of getting the same result.
Yeah.
Call it that.
So maybe we'll see an uprising in Monasca. So it was basically maintained by HP and Fujitsu. And now that like SUSE has acquired the HP assets of OpenStack, maybe they're gonna continue the project a little further, or I don't know, just an idea. So let me show you how this looks like. So Monasca actually ties into Horizon. So you on the left-hand side then have a monitoring tab where you could then actually directly jump into the Grafana dashboards that you have configured. So for example, for the compute service. Yeah.
It's a really long password you have.
It is totally highly secure. Again, it's for demo purposes. So yeah, compute, you could, for example, then just spin up the Grafana dashboard for this one specific metrics, which does, oh no, here we go. And yeah, it really depends on how you configure it and how far you actually drive it again. So we've seen that you guys over here drove it pretty far. And yeah, so I guess the basic differentiator is that it's maybe a little bit more complicated to set up. So I actually tried to set it up on my own and terribly failed at that. So Stacy actually helped me out and hooked me up with this, not the latest version of Monasca, but at least the version we were able to demo and to just show the integration into Horizon.
And if you want to test it, it's a Docker image that you get from GitHub.
Yeah.
And you just run it, and it's a stripped down version of all the basics to run at least the OpenStack dashboard and something that looks like a compute, but it's not. And the Monasca plugin, so it gives you an idea of what's going on.
Yeah. I think you can't actually start a VM there. So I tried to click around in Horizon and it says, not found, not found. I would refrain from doing that. But yeah, you get a feeling of what you could do with that. Here is a dashboard made with Grafana from my renters, for example. So they set up checks for all of their OpenStack services in the control plane to say, is it up, is it down? So just a section of the resource utilization of their overall OpenStack cluster, and then for individual VMs, for example, the CPU utilization, which is pretty nice. And they also, I'm not sure where I got that from, but it's like, of course, you have to monitor your OpenStack services, but of course also the supporting services like RabbitMQ, Memcached are also very interesting, and you need to have a look at them as well, because if like your RabbitMQ is full and you don't know it, everything, basically hell breaks loose and you don't know why. So there are like dashboards you could do only for RabbitMQ, right? All right. So let's take a look at what we actually did with OpenStack. So Dynatrace is not an open source solution, so Dynatrace is you have to pay for it.
Can I use an $1 bill?
Come again?
Should be a loony in there.
$1 bill, yeah.
Stacy told me that, but I just stuck with it, so it's okay.
Your pricing model is for $1 per click.
Well done. So about the architecture, it basically functions the same way as all of the other solutions did. You install like an agent on the OpenStack service node, so basically all compute and all controller nodes. You have, in addition, one component, it's called security gateway, which on the one hand bundles the traffic to the Dynatrace server, and on the other hand does calls to the OpenStack API to gather additional data. And yeah, basically that's it. So if you also want to get insights into the applications as we were just previously discussing, you of course would need to install the agent also inside your VMs for the tenants, so you get application data as well. So this is basically how the setup would look like in our now already well-known example application. You would install the one agent on the compute and controller nodes, which basically is the execution of a shell script you can download from your Dynatrace tenant that you get. And the same goes for the security gateway, which is also just the execution of a shell script. Then you need to configure the keystone endpoint, and that's all the configuration you need to do. You don't need to configure which metrics you want to know, you don't need to configure thresholds. That's it. Basically, you can set this up in, I think the record is somewhere by 2 minutes 30, so it's pretty fast. And now I'm just going to show you how that looks like. If I find my mouse. I can't see it. Can you? Yeah, I don't see the cursor. Shit. Okay, we're going to do this blind. Yeah, perfect. So this is, for example, the overview for an OpenStack environment, where you'll see like how many compute nodes you have, how many controller nodes you have, what is the health of the OpenStack services, what's the health of the VMs that are running. Below, we get into environment dynamics, so how many VMs have been launched previously, how many VMs are running, what is the launch time of those VMs, is like the launch time increasing or is it steadily? And below we go into like capacity planning metrics. So what is the overall resource utilization of my cluster? What is the resource utilization per hypervisor, so per compute node in my environment? And we can actually, I won't be able to. So it's really bad that I can't see my cursor because I'm clicking. Oh, I was able to hit it. Amazing. So actually able to see the individual resource utilization for each VM running on that hypervisor. So for example, you could see like noisy neighbors immediately also visually in this chart over here, because one of the VMs would take up all of the CPU time and the others probably won't get any. That's for the compute part. Now I have to, awesome. This is fun. So for the controller node, we basically list you all of the well-known OpenStack services with the overall resource utilization. So if you like run in HA, this is like how it looks for the customer side, for the consuming side of that service. So it's like an average of your 3 Keystone instances. And for example, missed it.
Maybe your mouse is underneath this.
Come again?
Maybe your mouse is underneath this page. If you
Yeah, it's nowhere right now. So
exit the full screen from the Chrome background page.
oh, you mean it's under the presentation? Oh, this would have been so much easier. But we made it so far. So this is, for example, like the overview screen for the Keystone service. Now this is for one of the instances of your Keystone service. So you get overall resource utilization metrics. You get like response time, so performance data. How is my response time over time? Is it decreasing? Is it increasing? Is it steady over time? So we also chart that, of course. You see like the availability of the service. And we immediately link you to all of the log files that actually Keystone writes, where you can just click on view all log entries. And you can on demand just pull the files. We parse the log files, we analyze them, and show you, in a smart way, where we actually aggregate by count of same log message. So you not like see 1,800 lines of the same message over again, so it's just aggregated. And you can search for patterns if you'd like. Yeah, that basically was the part that Dynatrace covers on OpenStack. We of course cover a lot of other technologies and are totally good at application monitoring. But, okay, we talked about that you need to gather a lot of metrics, a lot of data, a lot of log files to actually get an understanding of what's going on in your OpenStack cluster. And what it actually is, it's all about correlation, right? So I bet you guys know a lot about correlation because I assume that in cancer research is a lot about statistics and then finding patterns in data. So basically that's all what's it about also in like trying to figure out what's going on in your environment. With all of the data you have, it's nice. It's nice you can do charts, it's nice you can do lists of events, but in the end, you need to make sense out of the data, right? And there's actually a good point because correlation doesn't necessarily mean causation. And now Stacy is hanging on the edge of the seat because now comes my stupid example for what correlation is and what correlation could actually be. So today we're going with the number of people who drowned by falling into a pool correlating to films Nicolas Cage appeared in. So my point being here that just because two variables kind of like correlate does not necessarily mean that there is a causal relationship behind that. So you could argue that like because Nicolas Cage appears in movies, people tend to drown more often, or the other way around. But yeah, you know, it doesn't make sense to look for a causal relationship where there most likely is none. There's Nick Cage. So here's another example, like more IT-related example. Let's assume you have a service that runs in your environment, and you know that its response time increased by 2 seconds. You just know it. And assume you have a host set that's CPU utilization spikes above 90%. If those two events happen at the same time, it would be a no-brainer to say, of course, response time is higher because the CPU utilization of that host is high, right? Easy. Wrong. Just because it happens at the same time does not mean that there is any relationship between those two events. Because those service B can run on a totally different host, and host C can actually host a totally different application. That's what I mean by correlation does not imply causation. So in order to actually figure out what's going on in your environment, you need information about the dependencies of the components and like the hierarchy and just like the architecture of your application. So let me make you even more clear what I mean by that using an example. So this is a visual representation of an application. So the user icons on top basically represent two user front ends, two user-facing applications. This is a business-to-business front end, and this is the end user front end, so to say. So this is like a demo application for where you can find journeys and travels and like look how's the weather in Tahiti and stuff like that. And here is like the business-to-business platform where third-party travel agencies can interact with your agency. Sorry. And the user-facing applications actually rely on several services, which are implicated by like the Tomcat service, or there is a MongoDB inside. So you see this application is using this service, this database, this service, and all of that is running on virtual machines, running on an OpenStack compute node. Just to get the terminology right. And now what actually happened is that one point in time, we had a new intern. His name was Danny. And his task was actually to fix a bug in the payment service. He got the assignment, programmed the bug fix, committed it to Git, and it got deployed. And then what happened is the response time of that service increased. Well done, Danny, so far. Then a few minutes later, something interesting happened. Actually, the user-facing application over here, the response time for that just also increased. So users couldn't book their journeys, make search queries. Just consider this, if it was a web shop, users could not get their checkout process through, right? And they would just switch back to Amazon because Amazon works and your shop doesn't work. So basically it has impact on the revenue you're generating. And in the end, all of the cloud platforms that we are using are here to run applications that provide some kind of service, that provide some kind of value to someone else. And if that isn't running, if the end users and customers are not satisfied, it's bad. And after some investigation, we found out the service runs slow. So the end user application is slow because the service it relies on runs slow. And this is slow because the service that relies on runs slow. And that. So it was really, so it kind of was like almost happening at the same time. And after we dug even deeper, we actually found out what the problem was. Since this service was like the response time was increasing, had actually the effect that also the CPU utilization of those virtual machine was increasing, which had the effect that the CPU utilization of the whole compute node was increasing, which also had the effect that there was not as much computing capacity left for all of the other virtual machines. So basically, Danny was able to screw up the application over here by fixing a bug in a totally isolated application, which is pretty cool if you think about it. But it's also pretty awesome actually to find that out manually, right? You would have to browse through thousands of log files, thousands of metrics, several of charts to get to the bottom of this. So we covered a few things now. So we have to talk about OpenStack service availability and performance. The same for the supporting services. We need to know about resource utilization and capacity. We need to know log analytics, because OpenStack is very heavily relying on log files. We need to know about the applications that run on top. And usually those applications run in some sort of PaaS, so Cloud Foundry, OpenShift, Kubernetes, you name it. Then, of course, we need to know, do any of those issues that we might face have an impact on our end users, on the users of the platform? If you're a public cloud provider, on the users of the public cloud platform, right? Then, so this is the other example I usually use, where like the amount of beer you drink correlates with how drunk you are, so you also get that. You need to make sense out of the data, so you need to correlate everything, all of the metrics, data, and log events. And you need to know the dependencies between your application components and like the architecture that's behind. And if you actually miss out on some of that, you have blind spots. Take the example from before and imagine analyzing that with your Nagios dashboard. I'm not sure if it would work, honestly. And to top it off, this is not a regular size application, right? It's like 2 web applications, a few services, 2 hosts. Usually the application environments that we at Dynatrace see look something more like that, where you have 100 hosts, 10,000 processes, 3,000 services, 7 different data centers, 9 applications. So it's gonna be, you're gonna have a real hard time manually hunting down one issue in this environment. That is why you should actually choose for a smart logging, smart monitoring approach. And it actually lies in your hand if you just start with an Nagios with 3 checks, if you want to go to war with that. What if you actually decide to pack up the whole fleet with destroyer and aircraft carrier and everything and B-52 bomber, like what you have done, George and Jared, with Elasticsearch and Zabbix and Grafana and everything, where you have everything under control. So basically what you need to do is you need to consider operations and maintenance up front when you actually start your OpenStack or your cloud journey. And then maybe Dynatrace would be the version where there are like 42 submarines that you don't see, that are actually also capable of application monitoring.
There were 18 submarines yesterday.
I know. We increased in size. All right, that's all from me. Thanks, guys. Are there any questions? Yeah.
So is it only accessible online, or is there an offline version of the product?
There's also an on-premise solution, of course, because our OpenStack customers usually tend to have a lot of servers and like to keep the data inside of the data center.
Is it pretty resource intensive, the offline version?
No. So we have one installation, so you can set up a Dynatrace cluster. And with our largest installation right now has like 7,500 agents, and this is handled by 3 servers. So, All right,
All right.
cool.
Thanks, Eric.
Thanks, Stacy.
Good job, man. All right. So that's it for our Q3 meetup. Thanks for coming. Thanks for staying also. That's always good. And we'll see you back in Q4. We're targeting end of November, start of December. If any of you want to present a talk, the idea of the meetups is always to have a local champion to tell a story of this is how we do things. And we're in Toronto, so that's what we're hoping for. And then, you know, we'll see for the rest of the speakers how things are going. But yeah, if you want to submit anything, just go to the meetup page and submit a talk request. More than happy to have local people talk at this event. So thanks again for coming, and that's a wrap.
That's a wrap.